Find the power series and interval of convergence for inverse tan x over 2 equals 2 over 4 plus x squared dx. So the first thing that we want to do is take a look at our integrand. If we divide everything by 4, we get 1 half over 1 minus negative x squared over 4. And that's going to tell us how to write our integrand. So we'll get 1 half, which we can write on the outside. And our series is going to be the sum from n equals 0 to infinity of negative 1 to the n, x to the 2n over 4 to the n dx. And this is going to be valid for absolute x less than 2. Now when we integrate, of course the interval might change, so we'll have to take a look at that in a moment. For right now, we're going to get 1 half when we integrate n equal to 0 up to infinity, negative 1 to the n, x to the 2n plus 1 over 4n times 2n plus 1. Of course, plus the constant of integration c. Now to find that, all we have to do is let x equals 0, and we'll get the inverse tangent of 0 halves, which is 0, equal to 1 half the sum, where x is 0, to the 2n plus 1. Since n starts off at 0, 2n plus 1 is going to be all the odd numbers, 1, 3, 5, so this is always going to be 0, so the entire sum is 0. 0 equals 0 plus c, so c is equal to 0. Now let's look at those endpoints. So if x is equal to negative 2, then plugging in negative 2 into our formula, we get sum from n equals 0 to infinity. Again, I'm kind of abusing the 1 half here. Negative 1 to the n. And this is going to be negative 1 to the 2n plus 1 times 2 to the 2n plus 1. But I'm going to write that as 2 to the 2n times 2 to the 1. And all that's going to be divided by 4 to the n times 2n plus 1. Well, this looks fairly complicated here, but keep in mind that 2 to the 2n is actually just 4 to the n in disguise, and that's going to cancel altogether. Another thing to keep in mind is that 2n plus 1 is always odd. So this is going to be negative 2, and you could always bring that onto the outside. What's remaining is an alternating series, and this alternating series has an equal to 1 over 2n plus 1, which decreases. Clearly it decreases. And has a limit as n goes to infinity equal to 0. So all in all, this means our series for inverse tangent of x has converges at x equals negative 2. Now, if we look at x equal to positive 2, get a similar situation. We're going to get, I'm going to ignore my 1 half here again, sum from n equals 0 to infinity, negative 1 to the n, 2 to the 2n plus 1, which I'll write as 2 to the 2n times 2 to the 1, divided by 4 to the n over 2n plus 1. And our 2's to the 2n are going to cancel. And again, we're going to have an alternating series that has a limit of 0 for the nth term, and that decreases. So this series converges at x equals positive 2 as well. So the interval of convergence is in fact -2, +2 inclusive.